This is Honors Algebra 2 Pre-Calculus, partial fraction decomposition, which is in our Chapter 6/partial fractions unit. So we're going to do example 2, which is, again, setting up the partial fractions decomposition, but not actually doing the decomposition. So remember, the first rule is that we have to fully factor the denominator. So in this case, I'm going to take out a GCF of x squared and be left with an x plus 5. So I get 2 factors, but I'm actually going to have 3 fractions, and here's why. X plus 5 is clearly a linear factor, but x squared is actually a repeat linear factor. This is like an x minus 0 quantity squared, for lack of a better way to say it. This is a linear repeat factor. It's not a quadratic factor that's prime. It actually is a linear factor that happens twice. It's x times x, right? So I'm going to get an x plus an x squared, right? Sorry, a blank over x plus a blank over x squared plus a blank over x plus 5. So I actually have 3 linear factors, right? And so that means that my numerators are going to be constants, a, b, because remember, this x squared is a repeat linear factor. It's not like it's an x squared plus 1. This is the same linear factor twice, and a c over the x plus 5. And that's going to be my setup. Again, that whole x squared thing at the front can be a little tricky for people. It's something we fall for a lot. Part B is going to require a little bit more factoring skill. So I'm going to factor this by grouping, right? If we walk through my factoring checklist, the first thing I should always look for is a GCF, which is what I did up here, and it worked out great. Awesome. But here there is no GCF, right? X cubed has stuff in common with the 2x squared, but not with the negative 8, for instance. So this is going to be a factor by grouping problem, right? The checklist when we factor is always look for a GCF. There isn't one. Is it a binomial, which this isn't because it has 4 terms? Is it a quadratic trinomial, which this isn't because it has 4 terms? Does grouping work? And in this case, grouping does work. If I group the first 2 together and take out a group GCF of x squared, I'm left with an x plus 2. And if I take out the group GCF back here of a minus 4, I'm also left with an x plus 2. So what I end up getting is x plus 2 times the quantity x squared minus 4, but x squared minus 4 is a difference of squares, so this actually factors into an x plus 2 times an x plus 2 times an x minus 2. So my denominator ends up looking like a repeat linear factor, x squared, or x plus 2 quantity squared, which is a linear factor that repeats, right, times an x minus 2, which is just a linear factor. So my breakdown is going to be the x plus 2 to the first, plus the x plus 2 all to the second, plus, and then this fraction with the x minus 2. And again, all of those were me ignoring the numerator entirely. Now when I go back through, all 3 of these factors are linear, even if they are linear repeat factors. So I'm going to get an A, B, and a C, and that's what this is going to look like.